Hello and Assalamualaikum students. Welcome to another video of study with ARS. Today's our topic is Dalton law of partial gases. Okay, so now let's look at the statement provided by Dalton. First of all, let's talk about Dalton. Dalton was an English chemist. He was an English chemist, and he gave this law in 1801. In 1801 he provided this law. Okay, so this law says that the total pressure the total pressure of a mixture of a gas, for example, like air, the total pressure of a mixture like air, we are having a lot of gases in air, like we are having nitrogen, oxygen, argon, like that. The total pressure of a mixture of gases is equals to the sum of their partial gases. What is the meaning of partial? So means the partial meaning is the individual, you may say. In this sense, here it is being using as the individually, but the literal meaning of partial is means to half. Okay, means the half, like for example in covalent bond, we sometimes we used to say that there are charges. For example, chlorine, we used to say this is the negative partial charge on chlorine, this is the positive partial charge on hydrogen, like that. Here it is not been using in this sense it is been using cause of to say the half, so that's why we are using partial. So the mixture of gases, the pressure of mixture of gases is equals to the sum of their partial uh, partial components, you may say, components or individual gases. Individual would be better than partial, because uh, some of them will not understand, some of you guys will not understand about partial, so individual gases. Okay, so this law basically states that for example, here we are having a container. Okay, and it is having a fixed volume, and yes, uh, do one thing in your mind, do one thing, memorize in your mind that in this law there would be temperature and volume, both will be in constant. Okay, they both will be in constant amount. Okay, they will not be changing. Okay, so now for example, here we are having a container which is having one gas like oxygen, and here we are having another gas like N2. Okay, and for example, pressure produced by this container is 400 torr. Torr is a unit of pressure. Okay, and this container has been produced a pressure of 500 torr. Okay, so what will happen if we will be combining both them in a single container? Okay, so for example, this is a fixed volume. Okay, this one volume, this one volume, these all three container are having the fixed volume. Okay, for example, this one is having 1 dm cube of volume. Okay, of a container, then this will also be having 1 dm cube, and this will also be having 1 dm cube. Okay, then here we are having the mixture of O2 and N2. Okay, and here we are having the pressure which will be equals to the total, according to this statement, the sum of the partial gases is equals to the total pressure. For example, here this one container is A and this one container is B. For example, suppose that. And now we have to calculate the total pressure. So the total pressure is equals to pressure of the A container add pressure of the B container. So here we are having 400 in A and 500 in the B container, so the total will be 900. So here in the third container we have got 900 torr of pressure here. And one thing more which is you may say important in this law, which is that if the gases are chemically are chemically changed, then this then this law would not be applicable. Okay, why? I will tell you. Applicable. Why I'm saying that? Because as you know, if oxygen and nitrogen will be chemically changed, then they can make bond. They can, for example, nitrogen make bond with oxygen like this, NO2 NO. So it can, so the pressure of this gas will be another pressure. Okay, so until the gases are not chemically changed and they are having the fixed volume and temperature, then this law is valid. Okay, and the formula for this law is total pressure is equals to number of mole of the specific gas divided by the total number of mole multiplied by, this is the pressure of a specific gas. Okay, multiplied by total pressure. And here we can also use as mole diffraction instead of writing this thing Na upon Nt, because mole diffraction is equals to N upon Nt, and maybe any of gases. Okay, here we are using A, so we have to use A here. Okay, so now we can write it like that: pressure of a specific gas is equals to X, which is a mole diffraction, will be product of the total pressure is equals to the pressure of an individual gas. So hope you guys like this and enjoy this today's lecture. We'll see you in the very next video.